Hello radiation enthusiast. If you saw part one of this video where we went to Radium Springs, Georgia and collected a water sample from the deep spring there, this is part two where we're going to actually test the water to see if we can detect the presence of any radiation in the water, since it does have, we've been told it has traces of radium or radium salts in it. And we're going to test that today. We still have the actual water sample, of course, and we're going to use about three different methods here. We're going to use a traditional Ludlam type with a Geiger-Müller tube, which detects alpha. Going to use my DIY scintillator, which I built from a kit, which works pretty well. It's sensitive. And finally, my favorite instrument is the Radioactive 102. It's a small scintillator type detector. Scintillator's right here in this little end right here. It's very sensitive to gamma. It's incredible, and it will also record a dose over a time period, whereas the other two, of course, won't do that. So let's get right into the experiment and see how it comes out. For our first test, we have an ordinary Corningware Corel brand plate. Small plate, a saucer if you will. We're going to put that down and we're going to pour some of our hopefully radioactive water into the plate, and we're going to check it with the Ludlam 44-9 probe, which is sensitive to alpha. And we know that the radium-226 is primarily an alpha emitter, although it does emit some gamma. And we're going to check first for alpha. Pouring a small amount of our spring water into this saucer. That should be fine right there. Now we're going to turn this on to the most sensitive position and see what we can get. What I have to do is get this as close to the surface as I can without touching anything. Seems to be picking up some. You can hear the clicks, but you don't really see the meter moving, hardly any at all. So let's take it away. Maybe hardly above background, if anything. Okay. Alright, next we're going to use my homemade scintillator that I previously had a video about. You might have seen it. Gamma sensitive only, so it has a very high background count, about 1500 to 2000 counts per minute, and so we'll see if it's picking up any gamma at all, which might come from this source, the spring water, the radium-226. So let's see if it changes any at all. I'm going to put it right into the water. It will be such a small change it's hardly discernible. We can't do any kind of a timed count with this Geiger counter, this scintillator, but it's something to compare. Hardly any results at all, I would say. Okay, let's move on to the Radioactive test. Here I have a plastic baggie that I've put spring water into. Now I'm going to put the Radioactive 102 directly onto the baggie of spring water. The baggie, of course, is to protect the Radioactive from getting wet. The sensor is up in the right-hand end of the Radioactive. It's the scintillation chamber where all the action takes place. And this is the iPhone app that pairs with the Radioactive, where you can read the results on your iPhone. Okay, let's check our results after 4 hours. We have 0.39 microsieverts. Dose after 4 hours time exposed to the Radium Springs water. So now what we have to do is do a control of 4 hours on the plate with nothing else on the plate. So set it back to 0. Now we're going to begin 4 hours of dose with no water present and use that as a control and see what we get. Okay, 4 hours have elapsed and we have 0.37 microsieverts. For the last test, I'm going to try to evaporate all of the spring water, which happens to be about 300 mils, evaporate it down to get the residue in an effort to possibly concentrate the active ingredients and make them more concentrated to get a reading on and see how that comes out. So here we have the results, a white crusty residue in the bottom of this container. Now we'll put the Radioactive directly into this and see what we get after 4 hours of sitting. Now at the end of the 4 hour period, let's check and see what reading we have on the Radioactive 102. What do we have here? It is 0.59 microsieverts dose after 4 hours of sitting in the residue. So let me get that recorded. Now we have to do a control of 4 hours sitting on the plate. No residue. End of 4 hours now by the magic of time warp. And what do we have? We have 0.32 microsieverts. So we compare those two, subtract one from the other, and we have the actual reading of what the residue dose was. So here's a summary of the results. First of all, the instrument was a Radioactive 102, in case you're not familiar with that. We just disregarded the first ones with the regular Geiger counter and then the scintillator that I DIY'd, you might say. So here's the results. The water in the bag after 4 hours, it gave 0.39 microsieverts as a dose. And then when we did the control of background for 4 hours, 0.37, leaving a difference of 0.02 microsievert. Not hardly anything at all, but at least it was in the direction you would expect it to be. Now in the residue, it was quite a different deal. It's pretty dramatic there. All after 4 hours, of course, 0.59 microsieverts. And then the background was 0.32, leaving a difference of 0.27. Pretty dramatic difference right there. Definitely what you would probably expect. And an interesting thing, the background was a little bit of a difference here, but it's pretty close, 0.37 and 0.32. Theoretically, I guess it could be almost the same, but it's always going to be a little bit different. Just like a blood pressure varies, you know, second by second. It's never going to be exactly the same reading. So I think the results are pretty satisfying. One thing I thought about later was the fact that I only used a small amount of water in the bag, just an amount that I thought would be easy to handle. If I had put the entire 300 mils in the bag, would it have made a difference? I don't know. I could do another experiment, but not right now, especially since I've already evaporated all the spring water. But maybe someone might know that answer. So other than that, I hope you enjoyed the video. If you did, there'll be more stuff coming kind of like this, so please subscribe and share. Thanks for watching.